create the, we have to check it, and yeah, let's move it. Okay, it's not right way to move it. Okay, I'm having a problem. And I would like to show you life hack that helped me very much, because sometimes, yeah. Let's go one by one, because I had a lot of questions. But for example, the node, as I showed you before, there is the structural properties, and you can click here, and you can check the releases here. Right now it's fixed, but if you'd like to, you can move it. But yeah, I don't like to move it, but you can put hinged anything that you want from here. Yeah, that's why it's very important to have the structural properties in case you want to use it and you want to modify it. But another thing about the load, if you want to put a point load, okay, maybe let me show you clearer, because it's not needed if you don't have other questions on this. Okay. But yeah, for example, what I was saying before is that, for example, I don't like this analytical model, and I have to change, and I want to change physically quite much, and I don't want to have this analytical model. What happened with me, usually the problem is that if you go back into the physical and go back into the generation mode, it will generate another analytical model for you. And it's very problematic. It can be problematic to have double analytical model. So what I recommend to do, in case I don't want it, because this is an analytical model, you see only analytical stuff, you can actually delete it. And you don't have it. You don't have to do it. I'm just showing you in case, for example, you want to do a completely different architectural model, and you make very big differences. You can just generate it anew. So you go back into Sophistic, for example. Yeah, I would just do it quite fast. Analytical, open, and I check it, and again. And now we have a completely new model again, but without this other things that we had problems with. Yeah, or for example, you get a new version from your architecture, from your architect, you can generate a new one from here. And let's check another thing, that the problem that could be in the structural analysis, that some nodes can be flying, or they can be unconnected again. How to check it in case you have a very, very big model and there are a lot of nodes and you cannot see it like here. I will show you another small hack. You go in, yeah. If it's a small change, like for example in the location of the column, you can move the analytical element. Yeah, you can move it. yourself, yeah, and the loads will stay. I just delete it right now because I didn't like everything. I just want to show you a new another thing, but you can change, move, as I showed you before, yeah. It does not update automatically, yeah. Yeah.
So at a certain degree, if there's a lot of changes,
Yeah, yeah. That's one of the downsides of this application, yeah. That's for sure, yeah. But again, if you will do the hosted load and you will move the element, it will stick to it. So if it's a minor change in the length or width, it can be changed. Yeah, the hosted load is advantageous, yeah. Yeah. Because with other loads, it will fly around. If you will move it, then it will show you an error. There is a load flying around where it goes. So yeah, let's go and how to see if the node unconnected, for example, or it's again like you have to give a boundary condition to it. You go into the view again and to our visibility and graphics, and what we're gonna do here is create a filter. So this is very advantageous for structural analysis, just to check that your nodes are all complete and your structure is statistically can be used later. We go into the filters and we create a new filter. And yeah, we go into the filter and edit new here. Yeah. And here we have a new one that we can create a small button here. And I want to check that nodes are connected. So I name it as unconnected, so it will show me as a filter which nodes are unconnected. So I create it as a rule of unconnected. Click OK. Oh, there is already one, but I will show you from a new one. Like that. And we choose categories that we'd like to use for our filter. And we are talking about the nodes, so we have to choose analytical nodes here. Okay, here you get it here on the right side. And what we want to do, what we want to check, that it's unconnected, that it's somewhere flying, and we want to connect it so it will be statically, the load transfer will be right. We have to check that it should be connected. So we choose the analytical node, and what we want to check is connection status. And again, if you want to check any other things, for example, you want to filter ground floor from first floor, you can change it. You can give whatever you want, so it's quite adaptable. But because we are trying to find which are unconnected, we choose connection status equals unconnected. So we define that any analytical mode which connection status is equal to unconnected will be shown. So after checking it like that, we're clicking OK. And we are adding it here. Add. And now we have this filter here because we just created it. And we put it OK. Now, I would like to have, for example, this node that it will show up, let's say, solid red. I choose override lines, and I would like to have a solid color of red. Just an example. Okay. Like that. And we go to OK. And voila, we have red nodes that will show up as unconnected. You can see here. Yeah.
So it's only the red ones that are unconnected now?
Yeah. Now you can see the red ones that you defined. It will show you and help you that these nodes are unconnected.
All of them?
No. Oh, maybe it's very hard to see. There are black ones and the red ones.
Yeah, okay.
Yeah, and as we defined it that the filter should show unconnected as red, the red one will show up as an unconnected. Yeah. So, okay. Another, this is one of the important things. Yeah, I'm just showing you some things from my own experience because later when if you would like to go, for example, into the BIM project, it will be very helpful for you to work with any other BIM Revit model and to use it structurally. It's very important to know these things, because if you're working in a very big project, it's important to see which node can be faulty, and you have to change something. But now I'm fine with this, for example. Of course, I'll put the boundary conditions here. Just a quick showing. Example. But okay, another thing about the load. As you see that there are a lot of load cases, and you can already imagine that if you will put all these winds, which are actually applied on one panel 4 times, this can be very problematic in the future for you, because, for example, if you would put F minus X, for example, wind in plus X, you will put it up here, for example, but then you want to put another one, for example, in the Y, let's say, minus X, it will be minus 4, for example. You will put it again, so it will be, it will happen that you will be probably lost in all these models. So my big advice is go one by one through each load. For example, let's go back into the load. For example, I'm defining wind plus X. So I defined the top. I defined, for example, let's say the line load on here. For example, this is a plus X. For example. So I defined all of them, for example, and I'm saying again. And now I want to show, and I'm done, for example, with the whole area, but I want to put another one, for example, from the plus minus X, and it will be suction from this side, as you know, because the wind will be coming from the east, from this side, so it will be minus here. Of course, you can put a different sign here and put it on here, but as you see, it becomes a problem later, because you have this suction pressure from all these 4 directions. So the big help that will be for you is using the visibility and to hide something. For example, because now I finished, for example, with X plus X, and I don't need to see this load variation again. I can choose, for example, let's work on one. And you choose this hiding, temporary hide isolate, and you hide the element. And now you don't see it. And what I can do, I can just hide all the plus X lines. And now I have a clean sheet that I can work with. And I can here define, again, all the plus X winds. I think this is all. If you have any other big questions, please feel free to ask. No, in Revit you cannot do it. No, in Cephastic you cannot generate. Well, at least in the plugin you cannot. Like if you are defining the loads here, you use only them. I think the Cephastic itself can do it, but when you are exporting it, it's problematic. For example, what I was doing, again, one of other things, other applications that you can use is Global RFM. This is a German structural analysis software, and you can. It's a standalone, but for this you have to export your whole model in IFC and then feed that IFC into your RFM or into any other softwares. I think right now most of the softwares can use IFC, so this is one of the easiest way to use it if you would like to. But if you want to, for example, make a preliminary analysis, which will be very quick, you can just put here some critical loads that you would like to analyze, And tomorrow, the next week I will show you how to use this tab. This is basically the actual analysis, how to create reports, how to find out the maximum forces. Yeah. Any other questions? If not, this is all. I will see you the next week to see actually the analysis. And you will also have the Sophistic assignment, the Sophistic worksheet. It's not graded, it's completely voluntary. If you would like to do it, you can do it. It will be released the next week. Yeah, this is all.